Hello, my name is Maria. I'm a software engineer on Quantum Systems team at Microsoft, working on education and outreach. In this demo, I will show you a variety of programming exercises and assignments that I developed for introductory courses on quantum computing. Quantum computing is a new computing paradigm that relies on quantum mechanical phenomena to perform computations. It enables new types of algorithms that are expected to lead to breakthroughs in many areas. Quantum computing is still in its early days, but even now there is a lot of demand for a diverse workforce trained in it. This means that along with building the quantum computer and developing the software ecosystem on top of it, we need to create tools and exercises to help people learn all aspects of quantum computing and quantum programming efficiently. All programming exercises in this demo use Microsoft Quantum Development Kit and its programming language C#. The first and the most broadly used type of exercises invite the learner to apply the theoretical concepts of quantum computing they just learned to solving practical programming problems. You can see an example of such problem here. It offers a signature of an operation that the learner must implement by filling in the missing code. The operation has well-defined inputs, in this case an array of qubits and an array of classical bits, and a description of its goal, the effect that the code must have on these qubits. Best of all, such tasks can come with testing harnesses that check whether the solution is correct, whether it accomplishes the given goal, regardless of the path it takes to accomplish it. They can be used to provide immediate feedback to the learner if the exercises are used for self-paced study, or to grade the solutions automatically if they are part of a programming assignment. A large collection of such tasks is available as the Quantum Katas, an open-source project that offers tutorials and exercises on a variety of introductory topics in quantum computing. The Quantum Katas are already used in multiple courses at universities around the world. The next type of tasks aims to get the student more familiar with the syntax of the language and the development tools available as part of Quantum Development Kit. Such tasks offer a program that implements an algorithm covered in class but has multiple bugs in it, and asks the student to find and fix the bugs. This code fragment, for example, contains two syntax errors, helpfully highlighted by Visual Studio IntelliSense, and one better hidden bug that will manifest as runtime error. It is also possible to introduce logic errors which will only manifest as incorrect results produced by the program. Such tasks can be very useful after the first few weeks of the course, after the students move on from the basic concepts to complete algorithms. They allow to bring attention to frequent mistakes done by students in their homework, to help them learn to debug their future code, and of course to check their understanding of the algorithm and the practical aspects of its applications. The next type of tasks is a more advanced one, suitable for the last part of the course. Remember that quantum computers are still in early stages of their development, so a lot of algorithms cannot be executed on them. This means that the students need to learn to use tools such as resource estimators, which answer questions such as how many qubits must a quantum computer have to run this program, or is this quantum algorithm faster than that one, without actually running the code on quantum hardware. This exercise serves as a great illustration for more complicated algorithms, such as the famous integer factorization algorithm, since they teach students to answer their own questions, such as, can we run this algorithm yet? There are lots of other types of tasks we can come up with to illustrate different aspects of quantum computing. I'm looking forward to meeting you at the virtual conference in March and talking to you about these exercises in more detail. Meanwhile, you can use these links to check out the Quantum Katas project and to read the paper presented at the previous CXCSA that describes our full experience teaching an introductory quantum computing course using these exercises. Please feel free to contact me with any questions you have before or after the conference. Thank you!